Okay, folks, so this is section 8.4, and I was asked to go through some of the story problems that we have in this section. So I want to start with the angle of elevation and the angle of depression. We will talk about this some in class as well. All I'm really going to go through with you is not so much solving the triangle or solving the story problem, but simply how to draw the picture. This can often be the worst part of the problem. If you don't get your picture right, frequently you're going to end up not being able to do the math correctly as well. When you're dealing with angle of elevation and angle of depression, notice I have this note here that says you should always, always, always start at the horizontal. So an angle of elevation is going to begin at the horizontal, kind of like our angle in standard position begins, and it's going to go up from there. The angle of depression will always begin, at the horizontal, just like our angle in standard position, but it's going to go from there down, kind of like our negative angles do. But the difference is that in a story problem, in something that's real life, we don't have negative angles, just shows direction on that. We're going to skip number 30, but I'd like to talk about a couple of examples. So this first example is about a helicopter. And whenever you're dealing with the phrase angle of elevation or angle of depression, you want to look for two specific words. You want to see where is your angle coming from and where is your angle going to. So as we read through this first question, kind of keep in mind that we're looking for a from and we're looking for a to. The angle of depression from a helicopter, 3,000 feet directly above an Allied mortar station, to an enemy supply depot is 13 degrees. Now, let's just start with that sentence. Since it's an angle of depression, I automatically know that I'm starting at the horizontal. That's going to be the very first thing I draw is my horizontal. And I know that my angle of depression is going to go down because that's what an angle of depression does. So according to this, my angle of depression is 13 degrees. Now, where does this angle begin? Where is it going from? Well, it's going from my helicopter. So I'm going to be a real fancy artist here. There's my helicopter. And it's going to an enemy supply depot. So if my angle is beginning here and it ends over here, then the ending of my angle is that enemy supply depot. So I'm just going to put SD for supply depot. Now let's look at where this helicopter is. The helicopter is 3,000 feet directly above an Allied mortar station. So let's just drop straight down. The helicopter is 3,000 feet directly above an Allied mortar station. I'm just going to say MS for mortar station. So then finally, I have all that I'm able to draw. Let's read the final question. How far is the depot from the mortar station? So I can go ahead then and I can connect the dots. And I can ask myself, this is my value of x, and this ultimately is what I'm trying to find. So that's how you draw the picture for the first one. Let's look at the next example. Two planes leave the same airport. Now what I'm going to do is I'm simply going to put a mark for my airport. Plane A travels on a bearing of northeast. Now I know there's an angle in there, but basically my plane is traveling northeast. Now let's talk about exactly what this might look like, and I'm going to go with a real pale color so that I don't mess up my picture too much. North, we all know that from the airport, if I go north, that's going to go straight up. But my plane is not going north. My plane is going northeast, and I know that east is to the right of north. So I'm looking at an angle, and I don't even care right now how accurate my angle is, but this is a northeast angle, and I'm told that this angle is 31 degrees, 20 minutes. And in a minute, when we have to put this into the calculator, that won't be that difficult. We know how to enter in degrees and minutes on our calculator. And this is where plane A ended up. Now let's go read about plane B. Plane B flew from the airport at a bearing of southeast. So here we have our, let me move this angle down just a hair so that it's actually at the airport. So south, there's my south, and I know that east of that, again, is to the right of that. And so there's my southeast angle, and that is at 58 degrees, 40 minutes. And this is where plane B ended up. Now let's talk about how far they flew. This is the direction that they flew. How far did they fly? So this, changing back into green here, both planes left at 1 o'clock in the afternoon. Plane A travels 200 miles an hour until 3 p.m. So plane A traveled for 2 hours at 200 miles an hour. So we know that plane A went for 400 miles. Plane B, again, left at 1 o'clock, travels at 300 miles an hour until 4:30. So this particular pilot went for, let's see, 3.5 hours at 300 miles an hour. So that's 1,050 miles. Find the distance between the two airports at which the planes stopped. So basically, we want to find the distance from the airport where A is, to the airport where B is. This is our unknown. That's how you draw that one. Let's go to the next one then. A ship sailing due east, stop. Okay, here's my ship. He went due east. We know that east is from left to right. A ship sailing due east at the rate of 16 miles an hour, that's going to be important in a minute, records the bearing of a radio beacon at northeast again. So here's the idea. You have a ship sailing. At one point, let's call it point A, at one point he sees a radio beacon. And then in a few minutes, it's going to say 2 hours later. So he's going to travel for 2 hours along this eastern pathway. And so when after 2 hours, he's at point B, he's going to see the beacon again. The first time he sees the beacon, I'm going to change back into gray for this, he sees that beacon northeast. So again, here's your north line. But that beacon is not straight north from where he's looking. That beacon is northeast, so it's a bit right of that. So let's draw something here. That would indicate northeast. And the angle of that particular view is 46 degrees, 50 minutes. Now, 2 hours later, and I'll deal with that 2 hours in just a moment, the bearing of the same beacon is northwest. Well, now the ship is sitting at point B, and now he sees there's the north line again, but that bearing is not straight north, it's northwest, and west is back to the left. So his line of sight might be something like this. Now, wherever those two cross over each other, this is where my beacon is. So we'll call it C, and C is wherever my beacon is. And that particular angle was 43 degrees, 10 minutes. How far is the ship from the beacon the first time, and how far is it from the second time? Now, I'll deal with those in class, those questions. But let's go back for a minute. We said that the rate of the ship was 16 miles an hour, and he went for 2 hours between the sightings. So 2 hours, 16 miles an hour. This ship has gone 32 miles. Now, there's some missing information. In our triangle, we really don't know any angles that are on the inside of our triangle. So one of our goals is going to be to find the angle on the inside of the triangle at point A, and we'll also need to find the angle on the inside of the triangle at point B. Have any ideas how I might do that? Okay, so bring these to class and we will actually do the solving of the questions in class, and we will leave the pictures to your time at home. That way you can pause, rewind, re-listen, etc. See you in class.